But still there is stuff that you cannot tell me. How is that possible? How we can cooperate with each other when I don't know the stuff that you do?
Okay. So it's complicated, but let me try to explain at least, with a little bit of, the shadow for the part that it's this part of the mystery of the things that probably we don't want to talk. So you're right. We are part of the same company, so colleagues. But the stuff that I work on, the assumption is that this is the part that really we don't want to talk a lot, especially outside. Even inside, the approach is like a need to know. It's one of the most probably strategic parts of the products, of the technology, of the things that actually Intel does. That is very, very common nowadays in the market. So AI, a lot of companies does AI. Intel also as being part of the industry. So everybody knows that we do AI, but some of the things are still not covered yet.
Top secret.
Not announced in the market, that they are actually top secret. It's one of the business values, business advantages, that it needs a good moment to be announced. Not too early, not to give any information that we shouldn't give to our competitors, and actually probably somehow also surprise our users, our customers, the market basically. Intel is an innovative company for many decades, actually more than half of the century. So yes, we are in the company that builds the future, builds next steps.
It's half of the century already.
Yes, as I counted today, it's more than 50. I think like 3 years back there was a big anniversary, like 50 years of Intel officially.
There was something like this, yes.
So really huge. I think huge time.
And then the CEO changed.
Yes, I think twice. Even. So yes, but we can say that we work.
I need to tell you that's a very good change. And by the way, Pat Gelsinger, because you're a guy from Gdańsk.
Yes.
You're working in Gdańsk.
Special day for Gdańsk.
Yes, special task force from Gdańsk, covering artificial intelligence. It sounds very, dense. And Pat Gelsinger was visiting our site, our Polish site in Gdańsk, and he was actually speaking to our prime minister.
Yes.
Have you been? Because you're a senior manager, I guess you've been on that meeting, haven't you?
So actually, I didn't have a chance to participate personally, but there was a representation of people from many parts of our company.
Okay.
To meet Pat and actually to show the site, to show what we do. I think this is a very important day for Gdańsk as Intel site. We have probably around like 3,000 people already working in Intel Gdańsk. So we are definitely important part of Intel globally and a strategic place. So we hope this visit will bring us more work, more strategic projects, and actually, we are very excited.
Yeah, because I was in that meeting.
You were?
Yeah.
Oh, you didn't tell me.
Just...
It's also one of the mysteries.
We discussed some logistics here and there. And after we finished up discussion about the future of our world and so on and stuff like that, Pat is coming to me and saying, hey, I know that you're speaking to Wojciech Ulas today. Just go tell these people what they want to know. Just go into all the secrets. Tell all the secrets. So you have the full permission to talk about the secrets.
Okay. So
can you tell a little bit more about that groundbreaking technology that we're developing right now?
Yeah, so I can tell you more. No, not all of the details, of course, even with permission for you, but actually no.
He didn't say so, but what I know from hearing is actually what is actually shocking me every time I hear it. What is the most shocking thing about AI developers and coders and data scientists that people tell about these people? You know, what's the most absolutely shocking thing?
No.
The worst thing is that those people, it's not my opinion, it's the street's opinion.
Okay. So
You guys don't do any sports. The only thing that you like to train is your neural networks, which is absolutely a back joke, I know. But do you do any sports?
Yeah, so like it's very interesting actually, you know, a really good way to describe people, like as you said, developers, data scientists, basic people that work close with the technology. I think what you just said, it's a bias. It's something that maybe may not be the truth, at least not for everyone, but for sure there is something. There is something regarding people.
Because you need time to develop this
Yes.
groundbreaking technology. It's not an easy thing. But you do some sports. Can you tell us what kind of sports do you do? If it's not a lie, because you're a senior manager, you definitely don't have time for such activities.
I agree. I know it's hard to find a slot, especially trying to divide the day. It's like 24 hours, so the time for sleeping, the rest for the day.
So you wake up at 5 a.m., 6 a.m.?
6 a.m. I like to wake up in the morning very early.
You enter your Outlook and then browse your inbox.
No, first try to eat something, coffee, then at least the walk, or try to run. It's very good moment, like especially in the very early morning. First to do some activities, it's really it gives really good start for the day.
Mm-hmm.
And then of course the work starts also in the morning. I have my family duties. I'm happy father of 3 kids, so
congratulations.
There's also the moment in the morning that I'm driving them to the school, then going back. Nowadays it's a lot of remote working, so
you're sitting at home?
Yes. We try to come back to the office, from time to time, but it's not yet the moment that we can actually go back. And it's one of the questions nowadays whether we'll be back to the mode that we were in before COVID. So majority of the week I spend at home.
Yeah.
So it's also one of the challenges, probably
Is it challenging because here your LinkedIn profile says exactly that you're the manager of managers. Is that some kind of management inception?
Yeah, you can tell like that. So let me tell you about my work, like at Intel. Actually, the group, what we do, and actually also what are my responsibilities. So we're located in Gdańsk as the group that actually focuses on AI products. There are more than 70 people in our group. My responsibility is to manage the development group. So 5 teams. I'm responsible for the 5 teams and for 5 managers. That's why this description that I actually work with the managers, but not only. We run kind of a flat approach for the whole organization.
Yeah.
So basically we talk with everyone. It's always like, being the partner to everyone who you work with. And this is one of the things that I really like about Intel, that it doesn't matter whether this is, our CEO or the manager or the engineer or whoever else from the company. We are the partners, and there's a full trust. Of course, there is this, part of the things that maybe we cannot talk like fully, not to, disclaiming some of the things, but the group in Gdańsk, going back to the story about what we do, we try to make sure that Intel is participating in the market of AI, bringing the platforms, the technology that enhance actually training the neural networks.
So you're very focused on training?
Yes, training. So as you said, I'm probably more training on the neural networks than training myself. as doing the exercises. So
You need to prioritize,
Yes,
this
of
is the
course.
work-life balance thing.
you are using the words
You
that
need
are
to work
actually,
on it, Wojtek.
Yes, you are a really good coach, Tim. So thanks for that. Actually, priorities is one of the things that probably is, in my dictionary, it's like a top 10 things.
Yeah.
So the challenge is how to prioritize the things. There are a lot of things to do, and me as a manager, I'm in charge of the group that has to deliver the product to the market, to the customer.
Is that software product, or is it hardware product, or is it a combination of both? If you prioritize your work and try to focus on specific projects, are these projects being a software development, or it is probably software development, but do you try to combine those two efforts, so software developing and hardware developing coming in parallel together, so you can have this holistic view on what the whole platform development look like? So what is your job cadence basically, and what kind of stuff are you developing?
So our primary focus is a software development as a group, but definitely the whole stack is a software and the hardware underneath. So we focus on the software part and its integration with the stack below. And it's actually a really good question. It's one of the things that when you try to deliver the product, which consists of the software and the hardware, like it's a question how to work on these both, either in parallel or at least to make sure that in the end they will work together. And like software development lifecycle, platform development lifecycle, product development lifecycle, this is the set of the steps that you need to do, like the first generation of the product, the second generation of the product. You try to put more features, more things that your product is able to deliver to the customer. So then you need to think about what's the most efficient way that you can organize the work, that many of the things can be done in parallel. So one of the things, it's a question whether it's possible to work, to co-design, to co-develop hardware and software in parallel. It's a challenge, basically. It's a challenge because there is a moment that you need to close the phase that you develop the hardware and then make sure that it will work with the software.
The scheduling problem is definitely
yes. It's always about the scheduling, the set of the steps that in the end will give the final result.
Yeah.
Our focus is on software, and I think this is really important because hardware itself, the best hardware itself nowadays without the software, it's something that.
Yes, and you basically know what is the architecture of the hardware that you will develop the software for, basically. Let's take a little step back because we are talking about training things, the models, artificial intelligence, but not everybody may be quite aware of what the neural network actually is. So we have this whole concept, or artificial intelligence in general, which is a software. It requires specific hardware to be run. And we know that most of the deep learning, because we're talking about training neural networks, which is a part of the deep learning technology. So the deep learning technology has been emerging for the last couple of years, thanks to the development of GPUs, so graphics platforms technology, basically. We know that stuff very well, but if you were about to define what the neural network actually is.
Okay. So let's maybe start with the first, artificial intelligence, like the whole domain.
Yeah.
It's the concept that the machines, the computers, are able to run the things, the activities, the tasks that normally require human intelligence. So the whole concept is, AI overall. Then the neural networks. It's a domain specific, so deep learning. The concept of neural network is pretty old. I think it started around like 1940s. So the idea how to mimic the way how the human brains work. So the whole concept about neurons. And the whole like timeline since 1940s till today, there were a couple significant moments and actually researchers that, as you said, finally we are at the moment that we have all of the building blocks needed to truly leverage the power of the neural networks.
And what does the neural network consist of? And what's the difference between human's brain axon and the neural network, which is the part of some software?
Okay,
what's the difference here?
So basically there are, I would say, many similarities. So we try to actually run something that will work in as much as possible similar way to the human brain. So neural network is a basically composite function, meaning there are a lot of math functions that are doing some calculations. And the whole concept is there is the input layer, so the first part of the neural network that you need to feed the data. And then there are some more layers, so also the structures of the, like in the human brain, neurons that are connected to each other, they exchange the information, they do some calculations, and they pass the signals to the next layers. So we can have, like 1, 2, 3, or even more, depends on the model, the layers that transforms the information, they calculate the data and pass the signals to the output.
So there is no black magic in it, basically.
Yes, it's sometimes we say that deep learning, the neural network is as a black box. You can train it very efficiently. It takes time. You need the data. You need to compute. That's why GPUs are.
I think that's because most of the researchers say that even fathers to deep learning technology, they say that this black box concept is being replicated in media because we don't really know how does the computer reason. There is no physical reasoning behind it.
Yeah.
But we don't really know how does that happen actually.
Yes, how the magic happens inside.
Exactly.
Yeah. So actually this is something that sometimes it's on the list of the drawbacks or the challenges. If we really would like to apply deep learning solutions, so trained neural networks to our life, it's sometimes the question whether really we want to rely on something that is giving the good results, but it's, as you are saying, how to explain what is the logic behind. So if we can compare, for example, deep learning and machine learning, deep learning is a subset of machine learning. In machine learning, you put more effort into define the algorithm and you can somehow explain the logic behind. So you feed the data in, then you try to set the list of the features. So for example, if this is the algorithm to recognize the pictures or to give the information what is in the picture or where is the particular part of...
I think it's called symbolic artificial intelligence.
Yes.
Because people think with symbols, and if you associate symbols with specific objects, that is...
Yes. So with machine learning approach, you need to invest more time into making sure that for the some extent you understand what is happening inside, and to drive to design the steps that are, for example, pulling out the features from the image, so the set of the points, the lines, the shapes. The advantage is that you need less data because to train really efficiently the neural network, which will be able to give you good results, you need to provide huge amount of data. So this is one of the costs of deep learning, huge amount of data, and also the pretty much long time to train the network. So accelerators like GPU or the other ASICs called, so basically the hardware that supports is able to efficiently run all of the computation needed to produce in the end the model that actually responds to the given task.
How much data do we need to train a neural network model that resides inside Tesla's computer, for example? Because we need, for autonomous driving, we obviously need that 99.999% of accuracy. What's the weight of the data that we need to train the model with?
Plenty. I mean, huge amount of data. From my past experience, also in Intel, one of the projects that we were working on was in the autonomous driving market area. So as we hear, on the market that many car makers are working on producing the autonomous car, like Tesla, BMW, basically all of the companies try to, there is a race on the market to bring the autonomous driving, and many companies like Google, Uber, there are like a different levels that you can say, like the level of how much the car can drive itself without human supervision.
Yeah.
To do that, for many years already, these companies are driving the cars that are collecting the data from the real drives. There are many appliances in the cars, like a camera, lidars, radars, and basically all of the sensors that are collecting the data during these test drives. And then the cars bring the data back to the data center, and it's a huge amount of the efforts to label this data, to categorize the data, to label the data, so the data can be used to train the models that will be given back to the car, and then
to make the model better and better and better. I think Mobileye got a license for driving their autonomous cars inside New York City to collect that data. I think that was something about 2 months ago.
Yes, I would say autonomous driving is a very, very interesting part of the technology and AI itself. Of course, there are a lot of challenges. First, collecting the data. Like from the one car, it's up to 100 terabytes of the data per day from 8 hours driving during the day, during the night. So there are a lot of things that you need to do actually to process the data. First to collect, then to transfer, to store, to label, use the data, and a lot of is happening.
So we can collect the data manually, like for our own purpose. For example, if Mobileye or Tesla would like to produce autonomous cars, they need to collect the data themselves because they're liable for what's happening with that car, basically. Yes. At the end of the day, you're responsible for that data that you're collecting, and you need to make sure that this is a good representation of training data that you are fitting your neural network later on. But what about your day-to-day job? If your developer teams are working on some kind of a AI application that is using certain type of neural network model, where do you take the data from? Where are the repositories? Is it public data? Are you collecting it yourself? How complicated is that process?
So overall, the process of collecting data it's a huge cost. And there are some of the sources of the data, like public data sets, like ImageNet as the example of already collected and labeled data that you can use. And this is something that you can use. Of course, if you work on some specific part of the market, of the domain, you need to collect the data yourself, like car makers. It's not something that you can get, at least nowadays, for free. There are some sets that are published to bring some standard to the market and actually to allow other companies to use the data sets. But it's one of the biggest costs if you want to train the model to really good efficiency, good accuracy. So it's basically something that works really good. The amount of data is very huge, and the cost to collect it is really high.
Intel is a big company, as well as Tesla. I don't know. Take any big corporation that is doing something with artificial intelligence. They can afford collecting that data. But what about smaller companies, ISVs, which would like to probably do some basic applications for face recognition and so on? how do they collect the data? Do they collect it themselves? I think from the business perspective, ideally, they would like to use some open source available data, which is out there. So here comes my question from your perspective as a manager. If you would like to, if you were about to guess in the next 10 years, starting from today, will neural network training process be isolated luxury, which will be a domain only for big players like, for example, CSPs, cloud providers, which are holding, the computational capacity in their hands. Hence, they have, they have money, they have compute power, they have data for training AI models.
Yes.
Will that be isolated only to that market region, or do you see any other option?
It's a good question. No, I would say in general, like which direction it will go, and I would say probably it depends on some specific cases. Definitely, we have big players in the market, like Facebook, Google, plenty of the data, and every day there are more and more data coming, like from our mobile phones, from all of the applications like that we use nowadays. It's the trade-off between the privacy and sharing your data, which can be used then also to build the data sets, build and trade the neural networks. Regarding ISVs, I think the case could be very similar to the situation right now as we have with the cloud services and the cloud. So for ISVs, it's the case whether to build something on premise or to go to the cloud and get something that is up and running, and from the cost perspective, it can be also more efficient. So the same way as we have infrastructure as a service, platform as a service, software as a service, then I think it's already happening like AI as a service, and probably same thing can be applied for data sets as a service somehow. So the data sets that are reviewed in terms of the proper balance of the data classes itself. It's also one of the risks. If you take the data and the classes are not well represented, like for example in autonomous driving, you can have a data set, so the information about the roads, but for example from the western part of the world, or not from the eastern, then if you will use this data set, it will give you the good training results for the models that will be used in the western part of the world, but for the eastern it will give very much different results.
Yeah, but still you see, they're already, we can already derive some geographical even parts of the world, where one part of the world will be dependent on the other. And we know that AI development is very dependent on democratizing this technology. We need to have an artificial intelligence technological democracy in order to let it bloom. Because innovation concepts are delivered not only by the big players, because the big players are usually focused on the profit aspect, but from the little players as well, even from students, especially those younger students who are brilliant. A very good example of it can be an AI for Youth program, which is being driven by my previous guest, Michał Joga, in about 11 countries right now, where students are coming up with all the great concepts for AI applications, but then they are dependent on the data collected by the big players. So the question is, if there is a big player with money who sits on the compute capacity, the data set, isn't that creating some kind of dependence threat to democracy in general?
I think it could be.
It could be.
Yes, I agree. And I think it's one of the things that at some point we as we as humans, so to speak, like that will be using artificial intelligence solutions, we need to solve somehow. So bring some structure. Probably it's about the policies, about the ethics, about the legal solutions that will structure and may make AI reliable. So as you are saying, like there is a risk that if someone has the power, like of compute power and the data set, it can be like the influence point on the others, leveraging the advantage of having these things to bring something that then will work for everyone. But to your point regarding ISVs and the students, like there are plenty of the startups, right? Companies, I think, especially like Silicon Valley, but not only, all over the world, like very smart people, coming from, many places, especially students. If you mention students, so for me, for example, as a manager, what I see, like, the last years, that the university bring many people that are very well skilled in AI already. So we have many students joining our company, joining our team, that are very, very skilled in AI already. So
how's that possible? Is the education so good, or are these students, the newcomers, are they, is it their hobby, coding and machine learning stuff or deep learning? Is it something that they feel good about, so they are exploring on themselves?
I think that the combination of many things, and also the things that you mentioned. So we already know that universities at the university level, all of the universities, like tech universities, they try to attract students, candidates, by running the specialties, AI related. So people after university are already trained, already prepared. Also, nowadays, like all of us has almost unlimited access to the knowledge, the training. You can
learning resources. Yes,
go to various set of the resources. It's even hard to pick, because you have like 100 options which course to take to learn something. So the options to learn are not limited, and young people, they are already born with the technology. So like 20 years back, internet was something new. We didn't have smartphones. There was no Google option, YouTube videos, online remote trainings to learn something. Right now, leveraging all of these possibilities, it's pretty easy to get access to all of these things and to get the knowledge. So that's why it's something that, again, from the team perspective, from our team's perspective, we are getting really good students that within the short time they are able to really be the high performers, even bring the knowledge and actually work in a way that is giving really good results, amazing results.
Speaking about talent, if you have these newcomers coming to you, what is the percentage between the female newcomers and the male newcomers? Is there a big gender gap?
I think there is. It's something that we know, based on the data. The ratio of people, if we have a job offer, the ratio of male and female candidates, it's like 10 to 90, 20 to 80, something between. It depends, but there is a difference. There is right now, like it's not a balanced, and this is one of the things that as you said at the beginning, we both work in Intel, and this is one of the things that I really appreciate. I think this is one of the really good things that Intel tried to do to make sure that we can do something with this situation. It's not only about the candidates for the job offers. It's going to the moment that people choose your career path, so decide which way to go. And Intel is also trying to influence, to actually attract, to show to both boys and girls the options, like working with the technology.
What are the ways? You're a manager, so you basically have probably a lot of recruitment discussions, not only with the candidates themselves, but also with other managers. What are the incentives? How does Intel incentivize the female part of engineering to come and become deep learning developers or data scientists, and how do we do that?
So, for example, one of the things, to show the options, to engage women to join the company, to join basically the tech market. One of the things that we as Intel we do, and in Gdańsk, it's very active part of also the managers' responsibilities to run the program like Women in Technology. This is program dedicated to make sure that we can make our pool of the employees balanced, to have more women working with us. So this is one of really good programs that Intel runs in Poland, and also globally. I think there are also many similar programs.
Does it work?
I think it works. We see the results. So, for example, in our group, there are not a lot, but we have women being part of the teams, and I think it's a matter of the time. We do the investment trying to attract more women to go to the tech university. So after a couple of years, there'll be more diverse pool of the engineers.
Is there any difference in abstract thinking between and innovative thinking, first of all, between women and men representatives of the developer zone at Intel? Is there any difference in thinking that you could derive from, the day-to-day life at Intel as a manager? Do you see any, all these I don't know how to say it, but usually there are some attributes when it comes to abstract thinking and that are different from each other when it comes to men and women groups. Do you see those in the developer thinking, abstract developer thinking, when it comes to code creation, applications, innovations?
So let me try to answer your question. So I think there is a difference. There is a difference. You cannot say that it's. I don't want to say that there are some defined way of either the thinking or behaving or working in some
we're
particular
not talking
ways.
about behavior, but
Yes.
especially when it comes to what I'm asking is whether there is some technology thinking gap which we as men representatives lack in our engineering work that those female candidates can fill up with their thinking.
Thinking about the examples, I know if that would be something that I can give the answer, particular to your question. But definitely, if we have a mix of women and men, as a group, we are more efficient to address and take into consideration different point of views. Like from my experience, if I would need to compare, actually I'm trying not to compare, but I think from my experience, working with women, there are more aspects like emotional intelligence, better communication. Actually, something that I can say even, me personally, these are probably, kind of my development areas to be, better at, like communicating or read the emotions. I would say on the technical level, I don't think there is, like a gap or something. It's just a matter of,
the way of thinking.
Yes, the way of thinking, and it's from my experience as a manager, but also as a father. I can tell I told you, like, I'm a father of 3
Girls or boys?
like 2 boys and a girl, and all of them are different.
Yeah.
Different way of thinking, different interests. So it's something that it's hard to say whether there is any pattern, but definitely also to your question regarding training the models, the data sets. So one of the things specific to the training the model is how can we avoid the bias. The bias comes from the data set. So the model itself is basically the level of efficiency in the end is strictly related to the quality of the data, the data given. So how to approach and how to make sure that we take into account when we leverage AI, even different geos, different way of thinking, minorities. There's an idea of the market to create kind of group of people, of the authorities, of the companies. It's called Partnership on AI. Also Intel is part of that. The mission behind this group is to make sure that we can take into consideration the diverse perspectives that will drive the way how we use AI in the way that it will bring positive outcome to the people.
So this data diversity is you say that potentially data diversity when it comes to data collection, different points of view. When there is a group of people that are collecting the data that have different point of views, different, for example, emotional intelligence, which is not bounded and isolated to some subjective thinking, it can get rid of that bias when it comes to model, right?
Right, because when you work with a data set, it's the matter. There are like different classes of If we take, for example, from the autonomous driving area, again going to the example like collecting the data in one of the geos or in 2 geos. If you collect the data from one of the geo and you train the model, then your car will be able to drive in this particular geo very efficiently. But if we take the model and apply it to the different part of the world, it can behave very much differently. Yeah. Taking the examples like, I like the example with the color of the cars that, normally when you say firefighting truck, what color is it's red, right? Mm-hmm. In Poland it's red, probably in Europe it's red. In Hawaii it's yellow. So if you want to apply the model to trend in Europe in Hawaii, for example, it will not work basically.
This is a very good example of something which is called actually IDD, so independent and identically distributed data concept. The first researchers from back in the 60s based their technology assumptions around the neural networks in a way that they considered data to be independent and distributed identically when it comes to the training data and the data set that we have around the world, which proves to be the wrong approach, right? Because you take the model from one part of the world to the other, and it happens that it doesn't work because we have the data not very distributed identically around the world. It differs even when it comes to the geographical aspect, not only technical aspect, right?
So I think the same applies to the group engineers. If you have just people thinking the same way, focusing on same area, you will not get the best results. because it's the matter of how much we can think in a different way to make sure that we can address all of the different cases that can then occur like in real life.
Yeah, so let's take a step back a little bit, because we're talking about also the future of deep learning. Mm-hmm. If we want to have efficient, unbiased models in the future that could resemble people's brain activity, mm-hmm. we need to make sure that this is definitely something which won't be racist. Mm-hmm. Yeah. Yeah, wouldn't copy the hostile behaviors of typical human. But before we move on to that future shape of deep learning, we need to take a couple of steps still. There are some bottlenecks in this technology that we need to tackle down. And one way of doing it is the innovation. Mm-hmm. If you take your developer groups as a manager, what is the amount of innovation portion in your day-to-day job that mm-hmm. you allow for to the developers itself? Because they can bring up their own ideas, right? There is no one size fits all, mm-hmm. definitely. No. But usually, not every company, and it's something that we all know, are allowing people to decide the way that they want to work. Like, so how is that at Intel? Mm-hmm. In your job and at your groups that you're leading, what is that innovation margin that you're allowing for? Mm-hmm.
So there is no constant ratio. We don't do like this. We say, okay, like 10 or 20% of the time people spend on innovation, but it doesn't mean that we don't do this part of the work. Basically, like 50 years of Intel, one of the things that still makes the company being like top of the market, mm-hmm. emerging technologies, is the innovation. So we as a group, especially in the AI area, we know that it's one thing is the matter of doing the business, so making sure that the real products go to the real customers. So basically the phase of ideas productization. And the second thing is always the question, like, what is the next step? So we are structured basically, but it's fluent across the group. We are structured that there are teams that their major focus is to make sure that we can bring the product on time within the expected set of features with the high quality to the customer. Basically, the idea, the concept, the design is already baked. So mm-hmm. it's majority of the work is software development in our case to make sure that it works. But there is this part that tries to address the innovation. So next step, like, what should we do as next step on the market? Actually, in many cases, Intel is present in many parts of the market. We are not a single product company. We bring the platforms, the technology, like horizontally in many places. And in some cases, we are, chasing the competitors or trying to, build a position on the market that are already the players, the other companies there. But in many cases, actually, we are driving the innovation. So we are, the first company doing the step towards a new direction.
But it has to be calculated, isn't it?
Yes, it's so right now it's a question, what should be the ratio? So from one time, mm-hmm. Intel, like all of the companies, we need to bring the profit to our shareholders. We need to continuously make sure that we bring the money. Then the question is, what part of your time, of the money, you should invest to make sure that you will keep the same or even higher return on investment, from the next set of the products. In our case, in many situations, this is the challenge for the manager to decide how many engineering, how many man days, how much effort we should spend on either production work or the innovation.
Do you have any statistics you could share?
I think it depends. Really, it can be.
Depends on the year.
Depends on the year. I would say it's close to 10-20%.
Okay.
It changes. We have the moments during the year that we all know that we are in the situation close to the release to the customer. So this is the main focus.
And depends on the customer, probably.
Depends on the customer. Depends on what phase the product is in. So definitely, when there's a moment that we start thinking about the next generation of the product, so this is the moment that we should be aware that this is the time to invest people to bring the innovations, the new features, new solutions. But across the Intel's group, many groups are purely dedicated to do the research, for example. So there is a lot of cooperation with universities, the other companies. People work on the things that probably we'll see in the market like in 2 years or even more. In our group, we have a mix, and it's also something that I think it's good for the engineers. You work on particular part of the product from time to time, or temporarily, or for a longer time. You can be moved to work, for example, on a new concept. It's also doing the match between the things like your skill set as the new engineer, your passion, and the things that the company needs from you, like the business value. If we can, match all of these things together, so this is ideal situation. So, from people perspective, you are still in the continuous round of also growing your skill set, your experience. And
yes,
again,
there's a lot of learning.
If it's combined with the passion, it's really like a perfect match.
Right. You mentioned cooperation with universities. Do the developers that are working for Intel working together with those research groups at the universities, or how does that work?
So I would say there are plenty, different scenarios that we, as the whole company, many groups, not only our group, my current group, cooperate with universities. So starting from the examples, like a local university here in Gdańsk, we did a lot of things together, like running the projects, giving the training sessions for the students, actually working through internships or longer cooperation. Many of people coming from that are like engineers in our company, they come from Polish universities. Regarding research, there are dedicated group at Intel's. Also, many group cooperates with the university of some kind of innovative approach. For example, how to build a way that there are different approaches for example, how to optimize the compute versus the time needed to train the network to the good accuracy. So one of the concepts is, what is the precision for the data that you will use during the training of the neural network. So in the end, you have good result, but for example, shorter time needed to run the training itself, and the lower computing power needed.
And I guess the key question is how to make the model recognize what kind of precision.
Yes, exactly. You can define the precision, but it's a question whether this is the most optimal way, or if this particular precision is really for the particular model really the best one. So one of the concepts is, it's a question probably without the answer yet, how to make it automatic during the training.
Could we consider it dynamic neural network, like a transformer actually? Because the transformer recognizes type of the data that is dealing with and transforms in the way that is the most optimal for processing certain type of the data. Is this something similar?
Yes, this is probably, like the concept of the transformers is related to the question like what is the next step, next big step for deep learning, for neural networks training. Right now the major top, let's say, 3 concepts is like supervised learning, unsupervised learning, reinforcement. Next step is probably the ability of the model itself to change itself during the training to get the most optimal result. So self-learning, autonomous training, you can try to call it in this way. The good example is the way how transformer type of networks can be trained. So it's also the question like what is next step after deep learning. Definitely we are not yet at the moment that this is the biggest thing that people can do in AI area. So it's a question, what would be the next step?
What is the next step exactly? The fathers of the deep learning said that exactly the dynamic neural network creation approach is something that we should be looking at for the future, definitely. So we could say that you're kind of contributing to this future of deep learning development.
Yes, this is really really exciting. Like again, working at Intel, there are many options, like what you can do as the engineer, as the manager. And one of the things that I really appreciate, like being Intel's employee, is that you can say, truly, really, you see the real things on the market, in the real world, that come out from Intel. So, ability to impact the world, the future, our future, the future of our kids, and the real impact of the things.
But we need to make sure that this impact is actually positive,
yes,
unbiased,
yes,
diverse, democratized.
Democratized.
Are we on a good path?
I hope we are. I hope we are.
You're the manager, you should know this thing.
So I can assure you that this is something that it's one of the key things to sort it out.
Yeah.
But to be open and honest, I think nowadays the technology is one step ahead, and we are not yet ready as the whole society, as the world, to have all of the answers to all of the questions, from the legal aspect, from the ethic aspect, to making sure that really we create a positive outcome from what we do in terms of AI.
So you can give your word as one of the technology leaders out there that you will work to make it democratic, diverse, unbiased.
I can assure that this is the only right way to think in that way. Otherwise, there are many voices, like from big authorities and the leaders also of AI, that AI is the next big weapon on the world. We can use it in a good or bad way, depends on us.
Exactly.
And we need to make sure that at some point, the whole concept of AI will not be something that will, as the population, will not get the bad results from whatever it means.
But you still have to work on that work-life balance to involve more sports in your life.
Yes, I mean, you are telling me the things that I'm trying to avoid, not to discuss, but I think that's it's important. Again, especially in the world right now, that if you work from home, it's hard to say when you start and when you finish. When is the moment that you are already in the family mode, not in the work mode.
That's right, Wojtek. Thank you so much for the conversation.
No, it was really
It was
great
a pleasure speaking to you.
Also for me, I watched your previous sessions, so they're really good. So I hope in the future I could say I was one of your guests when you will be really famous. And
let's hope so.
Yes, really, really. Thank you.
Thank you again.